Good afternoon, everyone. So this is JP Allard talking. So welcome to the Artificial Intelligence latest advances in visual inspections on production line. So there's a few people entering, but as I told you, we're going to start at 4:03. It's already 4:04. So let's begin. So the agenda today. First, we'll do an overview of the history of artificial intelligence since 1943 up to today, latest advances, which are machine learning and deep learning. So we'll do machine learning and deep learning. Afterwards, we'll do a case study of how Jekson has implemented in his BIS Smart, which is our blister inspection system, machine learning and deep learning. And finally, we'll do a quick overview of what are the new improvement in process for future products. All right, so this is me, Jean-Pierre, but actually everybody goes by JP, it's much easier, Allard. I'm the Vice President, Technical Sales and CTO here at Jekson. I have more than 25 years experience in IT technology. I have a bachelor's in science in electronics and microcontrollers. I'm what we call a Québécois, which is actually, it means I'm from Quebec, which is the Canada's French part. And so please forgive my accent. There's nothing I can do about it. I will try to talk slower, but the accent, we all have an accent after all. All right, and also just this picture has been trained with AI, so I don't look that good. All right, and today I have the pleasure to also have Pasquale Mirtuono with me. Pasquale is our colleague here. He's a director of the Innovation and Research Center here at Jekson. He has more than 15 years of experience in industrial vision systems. He has a PhD in multimodal imaging in biomedicine, a master in science in intelligent and multimedia systems, and initially studied in information technology multimedia. And not only is he working at the Jekson, but he's also a professor at the University of Verona in Italy for advanced programming in artificial intelligence. So we have really someone really knowledgeable with us today. So before we start, just a quick overview of what artificial intelligence means. Actually, it's everywhere. So the first example I want to show you is all these now new autonomous vehicle getting out with Tesla and Google as well, doing something on it. We also have speech recognition. So you might use Siri or of Alexa, for example. If you have to deal with people in other countries, I'm sure that Google Translate or similar software is your best friend right now because it works very well. Facial recognition. And finally, chatbots like ChatGPT is a good example. Obviously, subject of today will be the machine vision inspection. All right, so now let's go. Where did it all start? Of course, artificial intelligence today is practical, but initially it started more on a theoretical side. So in 1943, there's a new way of simulating a machine that has been created, which was called connectionism. And I'll go through it in the next few slides. Afterwards, 13 years later, the first conference was held, and the title was the Thinking Machine Conference in Dartmouth College. And there's more than 20 different scientists that joined in that first conference to discuss of how artificial intelligence could become reality. And actually, one of those that was at that meeting, a year later, made some kind of prophecy saying that the artificial intelligence will beat humans at chess within 10 years. Eventually, his prophecy became true, but it took a little bit more than 10 years. Why? The reason was that there was no microcontroller, there was no computer with enough power to simulate all the theories that these guys have put. So that's why after 1957, in the artificial intelligence history, we can call it the first winter, meaning that the winter, in cold countries, nothing is growing, so it's not moving. So for a lot of years until 1971, there was not much that was done. But in 1971, Intel released its first microprocessor, which then allowed scientists to now start again to dream and then having the power to be able to simulate the theories. However, about almost 20 years later, in 1990, The AI black box model now had anywhere between 200 to 300 rules, which had to be configured by humans. So it became very, very complex. It required a lot of effort, and nobody was kind of able to do something that was actually working. So AI became almost a taboo in terms of using this word to get fundings and so on in universities, and that's what started what we can call the second winter. But that was a little bit shorter than the first one because there's a big bomb that happened in 1997 when the IBM Deep Blue machine was able to defeat the world chess champion, the Russian Garry Kasparov. So you might remember this moment. Even though I was at that time still as a teenager, I do remember it. I think it was a shock. It was kind of finally a machine was able to defeat the best human on something that requires intelligence, and because of that, it kind of restart the movement. Now, when universities were asking for funding, it was much easier. Private companies were interested, and so on. So it make a big difference. In 2003, the theories that were not that touched since the 40s and 50s has been redesigned. So what we can call now the neural network redesign started in 2003, and a few years later, in 2012, the um, the AI done by Google was able now to recognize a cat in the in a video. So today it might be trivial, but think about it. It's only 12 years ago that it happened for the first time. Then in 2020, OpenAI released its third version of GPT that everybody knows as ChatGPT. So what is connectionism that I just mentioned earlier? So there's two scientists. First, Walter Pitts, which is an American mathematician, and Warren McCullough, a neurophysiologist. Somehow they started to discuss together, and then they had a great idea, which was to reproduce in a machine the human brain internal behavior. So the first mathematical model of the biological neuron was born. So if you look on the right-hand side, what you have on the top is a real human neuron. So a neuron has dendrites, which is like inputs that are connected to several other neurons. Then with these inputs, there's an output that gets out on synapse. So the mathematical model was exactly the same. So sorry, this slide is in French, but I speak French. I'll be able to translate for you. So first, we have values. So all these are all the inputs that are then multiplied by some weight. So for example, let's say you have to make a decision. You might have three factors, but each factor has a different weight. So that's what the model is doing as well. So it multiplies the input by a certain weight for each one. Then all these multiplication are summed together, and then the sum is compared with a threshold. And if it goes over the threshold, then you have the output. So that was the model. So the what we can call the connectionism approach was born. A few years later, then they started to think more about it, and the second wave started because we do not think with a single neuron. Actually, our neurons are all interconnected. So then the models became a little bit more complex. So the initial one, as you can see on the top, was now taking into account several inputs, but then with some kind of intermediate state that would consider all the inputs, and then up to, like, for example, this case, four different like thinking places, if we can even think, are generating two outputs. So now you can see that there was a sense of now interconnection, and the last one on the bottom is even better because now there's a concept of retroaction. So each input is multiplied, but also the result of everyone else. So the output becomes the input of the others. As I said earlier, these models were used for a long time, and it's only in 2003 that a real upgrade was made. These three people are behind it. So first of all, there's Jeffrey Hinton, which is from UK, working for University of Toronto in Canada. Joshua Bengio, from Morocco, working at Université de Montréal in Canada as well, and Yann Lequin, which is from France, working at New York University on Manhattan, New York. These three people are considered as the three founders of deep learning. And as you can see on the bottom right-hand side, deep learning is actually a part of machine learning, which is an application of artificial intelligence. For decades, they persevered with neural networks while the AI community viewed them as a dead end. But actually, the future proved them wrong because nowadays, Jeffrey Hinton has been afterwards hired by Google. Joshua founded his own company called Element AI, which is one of the main company working in AI right now. And Jan was hired by Facebook. It's not a surprise because there's literally a war right now in AI. Amazon, Apple, Google, Facebook, and a few others are all racing to get the latest advances in AI, and that's why obviously Google and Facebook were able to afford these two brains. Before we go and explain what they've done, what is machine learning and deep learning, I'm just going to stay at 10,000 feet up there, just to give you again, an overview of the two main categories of artificial intelligence. The first one, called the weak or narrow AI, is extremely efficient in a specific area of training. So these are applications that usually are doing only one task, that are practical, and they have been driven by the industry. So on the right-hand side, you see a lot of examples that you know. For example, the chatbots, even ChatGPT is considered a weak or narrow AI. The email spam filters, the smart assistants like Siri and Alexa, self-driving cars, GPS navigation like Google Maps, autocorrect features, Spotify Shuffle. You know, when you select a song and then the other songs are not even part of the library, but Spotify is considering all the other songs that other people like you that has similar libraries do like as well, and ChatGPT. Strong AI on its side is it's more complex. It's the ability to contextualize specialized problems to figuring out answers beyond just searching data sets. So, you know, a good example could be these robots from Star Wars that are able to do any task and sustain any kind of conversation like a human kind would do. So another example for maybe the older audience today is the movie from Stanley Kubrick that was released more than 40 years ago called 2001: A Space Odyssey, in which there was a big vessel and everything was controlled by a computer. And for those that that remember this movie, the computer name was HAL. And it's funny because Stanley Kubrick always put Easter eggs in every one of his movie. So if you look at the name of that computer, which was HAL, and you add one, which means that after the letter H, you have I, after the letter B, you have after A, you have B, and after L, you have M. So IBM, and it was kind of a good prophecy because eventually IBM was the first one to release a computer able to play chess and win against the best human doing it. There's also Isaac Asimov that did a lot of novels on AI robots. And believe it or not, but both Stanley Kubrick and Isaac Asimov have been close friends with a lot of actors in the AI community for years. And even though they are working more on on the artistic side, if you can say, well, they have been thinker and they have contributed to the some rules that have even been programmed in AI. So, however, strong AI is still a dream and is still only science fiction, but it's really part of the official categorization of AI. So now, what's the difference between artificial intelligence that everybody claims to do, machine learning, and deep learning? As you can see, it's all subsets, and I'll go through one at a time. So first, I'll start with artificial intelligence. The simple definition could be when a machine is doing a task that historically demanded human intelligence. Once again, I'll go back with that same example of a machine playing chess against a human. Why this example? It's easy to explain. To program it, the programmer simply program all the rules that every piece can do on a chessboard. And then every time it's the computer times to move, what the computer will do is to basically look out of all the possibilities from this turn, the next turn, and so on. And then based on statistically what would be the one that gives them the most chance to win, it will choose that one. So the computer is not thinking by itself. It's just using the rule that a human programmed. In the case of machine learning, it's different. In machine learning, it's algorithms that are there to imitate the way humans learn from experience. And this is a keyword, experience, because the objective here is to make prediction based on data from the past. So I'll give you three examples of applications that are used in today's world using machine learning. Like, for example, in finance, let's say you have your credit card, it gets compromised for any reason. Some person goes to the gas station, tries your credit card or tries a number by filling like $20 of gas. The AI is analyzing everyone and knows everyone's specific habits. So it knows that you never only put $20 of gas, for example. So immediately you will receive a text message telling you, was that you that bought this thing at that place 1 minute ago? And then, most of the time, no, it wasn't me. So obviously it's not a human person that is doing it, but it's redone using your own history. So once again, it's not creating, but it's kind of developing a kind of understanding what is your pattern. Retail, same thing. You go on Amazon, for example, you buy something, you put it in the basket, let's say, and then, oh, there's a few more suggestions that pops up. And these suggestions are not only based on what someone that buys that same object would also buy, but also on your own history. They know that, okay, you're the type of person that when you buy this, you might also buy that. And so they even put you in categories. And finally, well, in more technology space, speech recognition. So how now all these accents can be understood. So deep learning now is even like now a specific application of machine learning, and the idea is to imitate how the neural networks of the human brain function. So it initially requires showing with massive amounts of data. It's used in image recognition, text generation, and medical research. So I'll give you an example. For example, Facebook has done a neural network using more than 15 million images. So it knows everything about the humankind in terms of what are our colors, what are our shapes, and so on. So in this case, we're going to use the Facebook algorithm to put color in this image. Within like a fraction of a second, this is the image we just got. Maybe in the real picture, the kid on the left-hand side, on top one, maybe the shirt wasn't green. Maybe it was light blue. It doesn't really matter because what matters is if you look at this picture, you have no idea it has been driven by AI because these pictures are coming from so many examples that the color chosen by computer are making sense. I have this slide now to better explain the difference between machine learning and deep learning. So let's say we want to train a neural network so that it's going to recognize cars within images. So on the top version, which is the machine learning concept, well, we'll give to the computer, maybe thousands of images, but for every images, a human will need to label these images to tell the computer, is there a car or there's no car in the image? So this is called the feature extraction, and it's done by someone. Then the computer, using all these images that are labeled to have a car or not a car, will all classify them. And at some point, when the algorithm will work well, every time you give an image, the output will be there's a car or there's no car. Deep learning now, the difference is that there's no human interaction. So the feature extraction and classification are all part of now this neural network, which basically it's like somehow like a big black box that does all kinds of equation with the image and will find out its own result. So, and the advantage is at the end when it's properly trained, the output would not only be if there's a car or no car, but it might be there's a car, it's a pickup truck, or there's a car, it's a Volvo. So And the more images you gave to the algorithm, the more types of car you gave to the algorithm, well, the more like granularity it's going to be able to give you. So it's very powerful. So why AI is used now in manufacturing industry more and more? Well, first of all, it has been proven that there's at least a 38% productivity boost increase, 45% more value creation rather than status quo. Also, AI is a good way to limit the resource shortage because obviously AI is meant to replace a human. But not only that, think about it. Let's say now with machine learning, yes, you will have to spend some time to train the machine. That's correct, like a human being. However, when you employ someone and then let's say 2 years later the person leaves, what happens? Well, you need to hire someone else and also train someone else. Well, in the case of a AI, once your machine is trained, it's trained forever. It's going to show up at 7 a.m. every morning. So, there's a lot of advantages on this. Also, the companies that are moving to AI faster, well, they will develop durable competitive advantages on their competition. Another example to show you the power of machine learning and deep learning. So in this case, we have an image with a few features. There's the ground, there's grass, there's some kind of bushes behind, and there's a bench. So with the standard traditional artificial algorithm, it would take up to 36 hours if we don't tell the computer anything, just so that it will be able to classify each part. While in 0.2 seconds, the automatic learning will be able to tell you there's a road, a bench, a tree, and grass. This slide now is showing you all the different features of AI, I mean of machine learning and deep learning. Well, first of all, we have to keep in mind that like a human being, uh, um, an AI working with machine learning and deep learning algorithm will always be ready to learn more. So it's really based on continuous learning. Also, something very, very interesting is that the computer will discover implicit rules that you might not even have thought about. So, in the old algorithm, let's say, for example, we need to inspect a tablet. Well, in the traditional AI, will kind of tell the computer, okay, find the edge. There's going to be the long diameter, the short diameter. There's going to be the curvature over there. But there might be even other features that we don't even realize that are classifying them. While the computer now with machine learning is not even told that he has to look for length and this and that. He's going to find out with all the examples you gave what are the feature by itself. Something also very interesting is the tolerance to noise and variability. So the computer is trained to look for something, and if it finds it, whatever is around doesn't matter. A very good example I'll give you is that for those that are familiar with the software Shazam. Shazam is a software you can have on your iPhone or your Samsung. It records the music that is playing right now in the room and tells you what's playing by comparing a little portion of the song with a library with millions of songs that exist in the world. If you go back about 5 years ago, before the latest techniques were developed, when there was a song that was getting played, what were you doing? We're asking everybody, okay, can you please stop talking? I need to know what is that song. Please don't talk. For the last 2 years, more or less, now you can be in a room with everybody talks. There's even it might be a siren outside, whatever. The computer will be able to recognize your song really quickly and regardless of the noise around it. So that's one of the great things with machine learning and deep learning. Also, obviously, the adaptation capacity. And finally, even creation capability. So just to emphasize even more on the continuous learning aspect of things, I'll give you another example in which we have to do the prediction of instabilities in metal transformation ovens. After 1 week of training the machine, telling if it was good or not, the accuracy was only at 10%. After 12 weeks, the accuracy was now at 95%, and we can imagine after a few more months, it's going to be close to 100%. And at 95%, by the way, it was already better than what an operator could do on a daily basis. Another example of the power. So here what you have is the two images just to show you part of the 15 million images that have been used to train the Facebook algorithm. in this case, the company AI Works, they have used the Facebook neural network and they tested with an image coming from an infrared camera. So no color, even though the Facebook um, neural network was done with color with images with colors. And in that case, it has been able to discover that there were four people, a car in that image, and using zero low resolution infrared images to obtain similar results. So it shows that the computer is only looking for color, but also shape and such. So that even now we gave the computer a black and white images, and it has been able to do it first thing. No, it's not perfect. So there's also limitations, obviously. The first one is it's subject to bias, and I'll give you a practical example. There's a contest now with universities that are competing for the last 15 years of how efficiently they can recognize something in their in a bank of images. There's a group in Ireland that they did it with sheep. There's a lot of sheep in Ireland, and they didn't realize that all the images they provided to the computer, every time there was a sheep, well, there was also grass. So the computer thought, in a way, that what they were labeling as being a sheep was actually the grass. So when the competition happened, they gave like an image with a horse, and the computer says, yeah, there's a sheep. And then, at some point later on, they found out and that actually the algorithm was looking for grass and not sheep. So which means that they should have gave examples, images with sheep without grass, so that way the computer will really understand that it was a sheep. Nowadays, there's even like better neural networks that are even recognizing specific animals and so on. So it's not like my example will not happen anymore today, but just to give you an example of when I say it's subject to bias. And it's the same with a kid. If you think about it, let's say you have a small kid at 2 3 years old, he starts talking, you start to have interaction with him, so he will learn a lot. Well, at some point you say, okay, this is a cat. And then maybe one day he's going to say, hey, daddy, look at this big cat. You say, no, no, this is not a big cat. This is a tiger. So it's the same with a computer. If you show him only images of cat, you might show a lion. He's going to believe it's a cat unless you tell the computer, well, no. And then the computer will find out by itself, like your kid would do, what is the difference between a cat and a tiger or a lion. The other limitation that it requires a lot of data. It's usually very specific, like all the examples I gave you. And like with my example with with the sheeps, well, it's a black box, meaning that we don't understand what is the algorithm inside because it's all like multiplications and so on, like simulating a neural network. And at some point, we don't know what the computer is using to understand what is or what is not a sheep. And most importantly, it's not magic. So we have to be careful around it. So back to what I explained earlier. Well, there's two types of AI. There's strong AI and narrow AI. So strong is more like it would be like a general intelligence, whereas what today we're working on is more applied artificial intelligence. So if we focus on the applied artificial intelligence, well, what is the idea? It's basically to do a task. So when you do a task, what do? Well, first you have some inputs. You see something, you hear something, then you'll think about it, what you're going to do, and then you do an action. So in terms of perception, well, the inputs can be the human to machine interface, like buttons. It can be by voice recognition and so on. Then you might have sensors, Internet of Things, and obviously social media for applications such as Instagram and Facebook are doing. Then the decision making, so the machine learning. Well, an important part nowadays is called the NLP, the neural language processing. So in this sphere, we have speech recognition, natural language understanding, and natural language generation. Oh, and by the way, just something else I just thought about telling you, speech recognition. I'll give you a personal example. I have this French Canadian accent. We're like 8 million in the world to speak it, so it's not the first thing that the programs will develop. Let's say. So when 10 years ago there was like the first assistant like Siri, I had to imitate an accent from France to be able to be understood by the computer. But for the last 5 years now, I can speak with my own accent and because of machine learning we're still 8 million people, which is like, it's not zero. So nowadays it's like I can talk with my natural accent and no problem, the computer understands me. So also natural language understanding, and finally natural language generation when the computer talks with you. And now what we just explained earlier, like the supervised learning by giving images or other examples, unsupervised, like with deep learning where the computer will figure out by itself, or reinforcement learning, which means that when we look at what are the outputs of the algorithm and we tell them this is good. So for example, your kid telling you, "Hey daddy, this is a lion, right?" So you say, "Yes, this is a lion." So when you do that kind of reinforcement, it's also a way to that increases the the factor they will give to some of their decision factor, because you're telling them, well, this your decision worked. And the last three are what is really part of deep learning. Finally, on the action side, well, once a decision has been made, should we do? Well, there might be a robot involved, a cobot, which is a collaborative robots, drones, vehicles, control, and obviously on a packaging line, that would be the ejection device that will eject the bad products, information system to look at statistics, to look at real-time reports, and virtual and augmented reality as well. So I've told you a lot about the things, but I didn't even tell you about Jekson. So I'm sure that most of you know it, but I'm just going to go a quick wrap up. So Jekson has existed for more than 22 years. It has more than 8,500 installations worldwide, more than 500 customers, 25 different products, and we have served more than 95 countries. So what do we do? Well, we do vision inspection systems, traceability for industries that are requiring serial numbers and aggregation up to packaging levels and traceability. Also, server solutions at level 3, which is your plant server, and also level 4, which would be your corporate server. At the plant, it might be to gather all your label layouts, gather all the statistics, the audit trails, and so on, the serial numbers. And at the corporate level, more or less the same thing, but also to connect now with government agency, what we can call L5. And finally, we have overall equipment efficiency solutions available. We're a global company, so our four major points in the world are, well, first of all, in India, where it's the headquarters of the company, more than 250 people working there and 2 plants. Then in India, that's where the design, manufacturing, and development center is located. In the US, we have the mechanical design that is now made for the company, and also part of manufacturing for the North American and South American customers. In Italy, this is where we have our research and development center to do artificial intelligence. And finally, in Brazil, we have a service and sales center for South America. So talking about Italy and our research center, this is when I will now let my colleague Pasquale, that you can turn now your microphone, that will now explain us how the BIS was now upgraded to now what we call the BIS Smart. So BIS stands for the Blister Inspection System, and Pasquale's team has worked on BIS Smart, which is now the same application, but now using machine learning and deep learning. So welcome with us, Pasquale.
Ciao at all, welcome for the gentle introduction. JP, we decide to share my screen, so I will do. And thank you everything to be here. Sorry for at the beginning for my accent. They asked me to speak very slowly, so in the case something is not clear, please use the question and asking session where somebody already asked something, and ask whatever you want that we will take at the end of the presentation and we'll clarify again. So also thank you, JP, for the introduction of me. I'm here now in Italy, and I want to start to present you something about our products. In particular, I want to focus in one specific field that is also the name of part of the name of the company, because we are talking about some vision inspection system, and in particular I will focus a little bit regarding BIS and BIS Smart. Both systems are built by Jekson to achieve the target of blister inspection system. And Jekson in this can be considered for here one of the best solution provider. This established Jekson as a leader of this solution. But if we consider BIS the first, I can say, motor of this type of inspection for Jekson, Jekson in some way decided to elevate this level, the current level of this application, just to reach what also the market is asking. And by supporting this type of innovation, we decide to introduce AI in the new product that is called BI Smart and was launched in 2020. Oops. Okay. So I already mentioned it before, but it's better to highlight with this particular slide. One of the most important reasons why we introduce AI is related on to the more demanding on the market. In particular, defects becomes increasingly more difficult to detect. We are getting smaller defect, and also shapes and color change drastically to fit any kind of production. So this task create the job of standard computer vision engineer more hard and more complex. What happens is that the algorithm to take a decision based on this type of inspection becomes difficult to configure, and also with less efficiency in general. So this was, I can say, the two main motivations that allowed Jekson to start the usage of deep learning and in general any kind of artificial intelligence in our company, in particular in BI Smart. So let's focus now on this. This is a small video where we have the comparison between standard BIS and BI Smart. So I would like only to focus on BI Smart because is one of the most important things that we have to take care. So in BI Smart, what is happening is that we just provide an empty blister. We provide a blister with good sample, and finally we provide some reject sample into the image. So what's happening is that automatically BI Smart is able to calculate any threshold for localizing, segmenting, and detecting also defects. So this is fully automatic. So let's focus now on what is the philosophy that is applied to this part. So we talk about philosophy because in principle it is a new concept to use algorithms. So what happens? There is one algorithm that we know, and there is a set of parameters. These parameters are looping between the ground truth and the algorithm just to obtain the best performance of the system. So it means that based on good and bad, we are able to optimize, and in some way we put the user in a different level respect to the past, because we don't have to increase or take too much care about the knowledge that any user need to take care when they need to configure an algorithm. And this is one of the most important things why we use many AI techniques. And on the right side of this slide, I want just to show you something, an example that explains you how it works. So most of the people that are now connected know very well the challenge that we have in BA Smart or in any blister inspection system. The foil that is composing the one of the part of the blister can be reflective because we are using reflecting material like aluminum, so alloy. So what happens, depending on the position of the product and in the cavity and the lighting system, the shadow can have multiple effects and can move with, I can say, no control. What we do with the machine learning algorithm is to implement a solution for foreign particle that take in consideration all or many of possible good sample. So means that we just put one or two image with some blister filled with good products, and based on the observation of foreign ground, or I can say the space that surround the pills that is highlighted here in white and with some preprocessing, we are able to generalize the concept of color that are normally present in the good cavity. With a clustering algorithm, we are able to generalize this concept, and then our inspection algorithm works that any kind of color that is out of this range is a foreign particle. So this is a simple explanation how we work with this that is in proper dictionary of computer vision science. It is called supervised learning. JP already explained it. Just another two example of algorithm that we are using in production for BA Smart is the automatic localization. We have a good team that is working to provide a pre-trained network that is able to localize any kind of cavity with the training of YOLO. This normally is called object detection task. And when all the cavities are automatically identified by this algorithm, then a new deep learning algorithm comes to resolve the segmentation task. So by using UNet, we are able to identify the main colors of the pills. And this is, I can say, for the final user, totally transparent. So I take 2 minutes to explain this slide, but I can say that all of this, as I presented in the previous slide, is fully automatic because you just need to put one good image, the empty blister image, and some defects. So let's talking about the improvements, because okay, I can talk for hours about how the BA Smart is developed, and I have to say for sure thank you to all the software developers that are following us into this journey, because introduce AI is also a journey. But I want to focus for you one of the important things that you have to take care. Normally, we consider this as take-home message. First, we have some quantitative improvements, and they are very clear and easy to explain. So we have increased the efficiency of the system by reducing the capability to detect small size variation, small length variation, broken and chipping products, but also color spots. But also one of the quantitative improvement that we easily explain is the time to teach a new product from 15 to 5 minutes. This is only quantitative, but is not enough, because when we are talking about simplified and sequential teaching, and we say here that is user friendly, we are not highlighting one particular things. So the most important thing is that the operator has not to be qualified to understand all the algorithm and all the recipe in the background that is running to assess for a good recipe. And this is very important for all customers, because this means that the recipe is not user dependent. And this is one of the critical points that we have to take care about. Another point to take in consideration is the validation. So I was from the beginning when AI started to join into the world of industrial environment. And this was one of the most critical part. But I can say that sometimes we are not properly understanding how a deep learning system is running in production. First, we have to consider one point. Everything that is developed in many inspection system company, but in particular in Jekson, is that a system can be considered valid if is developed and tested, but also designed under GMP. So it means that if you're following GMP, for sure you have a system that can be validated. Second point, and this is a very important task for this type of the scope of this presentation, is that any machine learning or deep learning system, as was described in the last version of GMP5 for describing and qualify how a system can be considered valid, is that these new elements are considered like a subsystem. It's like a statistical filter that you put during the teaching phase, you train, and when you reach the performance that you want, you just lock and you use as it is, as a standard filter, like a segmentation filter, like a standard edge filter. It's like a component that you use as it is. So there is no risk based on the usage of this in the production environment. So this is my last slide, just to explain that everything for validating a system is already present into the framework that we are using. Is also very well described into the institute that take care about our I can say points for push a lot customer, solution provider, and also qualification engineers to take care about how we build our system. We just need to consider that deep learning can simplify a lot and can take many guarantees that we need from our vision inspection system, because with deep learning and machine learning, what we are looking is to have a system that reach the performance that we want in production. And this can be guaranteed with the basic of the deep learning, that is a statistical performance measurement of our inspection. Thank you very much at all. I will pass again the word to JP, that is now ready to continue the presentation. He's already sharing the next slide. So thank you very much. And for any question, please ask. We will answer.
Thank you, Pasquale. So exactly. So as Pasquale explained, you can at any time use the chat to send us your question, and at the end of the presentation, which is coming very soon, we'll go through all the questions. Thank you. So maybe one last thing about validation considerations. Well, just to reassure those that could be afraid of using AI, that could be like not something not validated. Well, as traditional visual system, the algorithm is not modified during the production. So what Jekson has developed with machine learning and deep learning is really techniques that are used to teach your new products, but when the teach is over, the algorithm stays the same during the complete production. And breaking news, in order to optimize recipe, we're going to add in the next few months a new button, which will be called recipe optimization, that will be only available at the batch end when the batch is over, that will let you look at all the images of the ejected products. And let's say, for example, you have 15 ejected products, but 5 of those you would not have ejected them. Well, now you'll be able to tell the computer, well, these 5 examples, please consider that as good for the next batch. So then this will use these new images to optimize our knowledge of what is a good product. And then the next batch, we will now use a improved algorithm. Of course, an editorial, when this button is used, will be recorded and the recipe version will be incremented. So now in terms of improvement in process, so we're currently working on our barcode, pharmacode, OCV and OCR platform to now allow machine learning and deep learning to identify even like now the type of barcode and so on now will be done automatically by the machine. Using the what we have developed for the blister inspection, we're now doing the same for the slot filler inspection. That is when you need to put tablets in bottles, and same thing for electronic counters. So in 2024, there will be the PAC Expo in Chicago and also the CPHI in Milan. And this is where we're going to show now our new tablet inspection system, the TIS Smart over there. And in 2025, the Line Clearance Deep will be a new platform we're going to release. And finally, something very exciting in 2026, we'll now have a cloud-based AI platform that will allow now to share, because something we haven't explained since the beginning is that, let's say, for example, you want to train our Be Smart with your new blisters or your new tablets. You only need to show us 5, 6, maybe 20 pictures, and it's enough. Why? It's because we have trained our neural network with like thousands of pictures of all kinds of tablets. And this is why the computer already knows what a tablet looks like. And then when you give your own pictures, it's just to now specify your actual product. But the computer already knows it's a tablet. It's like facial recognition. The computer is looking for a face, but then it will recognize your face, and it doesn't need thousands of pictures of your face to recognize your face. But in order to recognize a human face in general, like literally like 10,000 more images were needed. So as we'll improve our library, well, at any time now, our customers will be able to connect with our AI platform to basically improve their algorithm anytime they want. So it's already time for the question period. So once again, please use our chat. We had a lot of people today on the call, so that's really appreciated. So we see it's a subject that was interesting. Obviously, we had a comment from someone that we want us to talk more about latest advances on packaging lines. I agree that this first webinar, we're more focused on more like, what was the history, how we come up there, and then there will be a sequel to this presentation with more details. But we felt that first, before going too much in the details of today's, we had to kind of give you the full history and also the big picture. So I hope that other people kind of like that fact that we gave you the big picture and also other applications at the same time. So once again, now we'll ask our moderator to tell us the questions, and we'll go through it.
Hi, JP. So
Yes.
we have a question. Do you have any use case on using computer vision for ensuring seed quality or purity?
Yes. So it's not, we don't have right now as we speak a solution for this. However, this is something which is totally feasible and possible. If a human eye is able to recognize a good from a bad seed, obviously a machine can do it as well. So the person that asked the question, will contact you because it's actually a very good application for machine learning and deep learning.
JP, I want to add something. Just to Augustine that asked this one. So what we can say is also this: we have an application that is called Sorter, and in this system, normally we are able to inspect any product that is able to be sorted in by using a vibration plate. This vibration plate uses a camera from the top. And what we are doing is just to inspect pills, tablet, but we also inspect something different, for example, pallet or something like that. So in principle is very also, I can say, easy to start a POC for you, because we just need to change the camera to have a very high resolution for your application and modify a little bit the handling system just to be sure that the sorter is able to fit your speed that for sure you want to inspect. But in principle, the algorithms are very flexible and you can use for sure.
Is there any other questions?
Thank you, Pasquale. Please, panel, if you have question, can you please put in chat? Is camera inspection bottom of the tablet block spot or chip tablet? What is the percentage it will detect? In camera inspection, if you turn camera on tablet block on the bottom, what is the percentage of detection of the camera defects on the tablet?
Okay, depends on the application. In BI Smart, we have two different solutions. One is the standard one that is applied for transparent foil, for example, PVC. And in this scenario, we can put a second camera that is looking the backside of the pills. So just by matching the inspection from the top and from the bottom with a stitching algorithm, we are able to capture the defect on both sides. For sure, in lateral point of view is a little bit different. In the sorter system, the evaluation plane guarantee a lot of the possibility to see many phases of the system. But I don't want to anticipate nothing. Jekson is studying with some university a totally new system to inspect pills and tablets in a way that is never seen before on the market. So there are many solutions that we have. In Blister, we already have something.
Okay. We have next question from Harish. What's the difference between Gen AI and AI?
Gen AI and AI, generative AI and AI. Okay. There are many possibilities to apply generative AI respect to AI, but I can say, okay, now it is the period when someone comes with a new terms and they try to create this type of question, but in principle are AI. So anyway, any techniques for a generative approach is very well used for a system that need to generate some data augmentation in some particular condition that you cannot use. And this type of technology enter into the standard AI framework because sometimes we don't have too much data and we cannot boring customer to collect million and million of data. At the moment today, also 100 sample, good sample is sometimes a challenge for a customer. And if you heard before that we need million and million of data to train a good and strong, stable network, you can understand that many techniques that are born recently to create some, I can say, plus value for improve the quality of inspection system can help a lot.
Thank you, Pasquale. We have next question. With smart camera, is it possible to detect slight chipped tablets with the same color? Is that a possibility?
Okay. Smart camera. Okay. Smart camera is a technology. I can say a hardware solution plus software. And in Jekson, we are using, but not only for AI. So the most advantage of smart camera is first introduce what is called edge computing. Edge computing is a novel techniques that many customers are applying, and I can say that we are very strong in Jekson because is used to distribute the computation on the edge. And this is a very helpful and funny application in order to make intelligent many applications. So regarding how to use I'm looking again the question. Smart camera to detecting slightly cheaper tablets with the same color. I can say that depends on the algorithm. For sure, in our application, in BI Smart system, that is not the smart camera, probably this is the misunderstanding. Yes, we are able to identify cheaper tablet of the same color. And also one of the most challenged part that we are able to reach with BI Smart solution is the white on white or gray on gray solution, where the challenge is to recognize the tablet that has the same color of the foreground and the background. So this is a more challenge part.
Okay. We have next
So probably
question.
I answer to Nitin.
Yes, yes. We have next question from Harish. Can we use recipe optimization for QR code inspection also?
Where is it? Sorry?
In Q&A.
Can?
Q&A. We have a question from Harish.
Okay, on the other chat. From Arish. Can we use recipe optimization for QR code inspect also? Okay, QR code already has some strong algorithm, and there is the second epoch of QR code algorithm that already introduce deep learning for automatically filtering, denoising QR code in a solution that we have presented recently to Akema, Germany, but is also going to be presented in Egypt and for sure will arrive quickly also in India. We will present the usage of a smart camera that use QR code inspection boosted with the AI solution.
Okay. We have next question. How Jekson apply
Yes.
AI inspection algorithm for the white tablet on white opaque inspection? So white on white.
Is in the chat.
Yes, yes. From Eric.
In principle, okay, in principle is the same that we have presented. So they are so when you take a picture of white on white, there are different color that arise. So in general, the workflow of the algorithm is based on first localize the cavity, and the cavity is localized independent on the color. Second, based on that, we are able to use a deep learning neural network to segment the main color of the pairs. But when you have the segmentation and you have for sure the color picked directly from the segmentation item, we are able to generate, I can say, a range of color that is able to identify the pairs uniquely. This color is slightly different respect to the color of the cavity because they are all the shadows that are presented into the projection of and the reflection of the light that first hit the product and second hit the surface. So this is one part. And the second part is also that nobody says in this meeting that we have totally removed computer vision techniques. There are many computer vision filters that we are using to restore and adjust and protect the localization and the segmentation of good pairs. So AI is a support for the computer vision part. It's not only AI, but mostly of the part is AI and is working in this way. So the color is not the same, and thanks to the UNet segmentation tool that I explained before, we are able to segment also gray on gray or white on white tablet. I don't know if I have answered properly. In the case, you can ask Eric again.
Okay. I'm combining two questions here. First part of the question is, can we use BI Smart in non-pharma industry? First part. And second part, can BI Smart is suitable for bi-layer tablets with different color of layers?
Okay, I was gonna answer this one. So like Pasquale explained earlier with our TIS sorter, which is actually the tablets are on a vibrating plate. Currently, as we speak, we already used it in the US for another completely different application. It was like bullet inspection. So it's actually a company that is getting bullets of different size, different quality, and so we look at each one of them, and then we're able to separate them. We're also working right now on another project, which is for the food industry, in which we're inspecting ingredients. So it's like chocolate chips and others. So which actually, like Pasquale said earlier, like for seed inspection, it's also something that the same technology could be used. Yeah. So I'll let Pasquale respond to the second question.
The second question is related for FMGC industry or what? Pushkar, can you repeat the second question because I see many and I don't know what. I'm trying to put a thumb on what we already answered.
So second part of question was, can BI Smart use for bi-layer tablets with two different layers, two different colors of the layers?
Current BI Smart is working with bi-layers tablet.
Yeah.
So the answer is yes.
Probably is in QA. Sorry if we take time but we have to chat to search all the question and answer. So please.
Maybe while you're scrolling, Pasquale and I, we are both world travelers, and we also have other experts in our team in India and Brazil as well. So for those that liked the presentation today, but that would have liked their team to listen to it, we're always open to go at your site, visit your packaging lines, and also give you this presentation to your complete team, and even go with maybe more detailed information. As you can imagine, through these webinars, not only we have customers online, but we always have sometimes competitors online. So we have to be careful of what we exactly say. But actually, when we go at your site, then we can disclose you even more information.
Okay, I will try to get some question from the chat. There is one from Nitin that is very interesting. Okay, so many times we say that AI require a lot of data and user doesn't have this data. I already explained this part. How we can use the AI if we don't have this data? First, because we are not training on the customer system a model from scratch. Normally, we are using pre-trained model, and what we do is we just fine-tune something on the same system. So fine-tuning is a technique that is widely used. I don't have to explain. And also to the competitors that probably are here to listen something from us. But what is happening is just to put some few sample, as I can explain before. One good example of pairs of good pairs images, one empty blister and some defect. I can say what 3 images, 4 images, 5 images, and based on that, the system try to extract some feature and finalize some machine learning algorithm to improve the, I can call it classification model, just to obtain the optimal threshold that you need for your inspection. So this is how it works. I see another one. Too much question. This is funny, but I like it. It is possible to measure thickness. Okay. Yes, this is a very interesting question. In the market, exists one company that is not Jekson that measure tablet and capsule thickness. We also tried this type of approach, but there is one problem related to where you are measuring. So if you have a blister machine that is able to create for you the blister, all the blister very precisely, and there is no possibility to have the blister, the pills that can follow in many way. Yes, you can have some thickness measurement. Otherwise, the suggestion is to don't use thickness, and you don't need the AI for standard sensor. So thickness is measured with imaging techniques and not with the AI. So based on some imaging techniques, and you can use laser sensor or stereo vision, you can create the image that you need for analyzing your cloud of point and then take a decision. With AI exist also some techniques to try to generate the model with one 2D image, but is not precise enough for the type of object that we are expecting. It's good to, for example, self-driving, where you need to don't kill somebody on the road because your vision system need to identify quickly and understand how far is a pedestrian. But yes, with AI, normally we just process what we are able to get from sensor, and in the sensor, from the sensor point of view, thickness is something that is not very well used because there is this artifact at the beginning. So it is where the piece or the tablet is posed.
Okay. So Pasquale, we have an interesting question about BIS. Can we use bilayer tablets with different color on BIS? That's the first thing. The customer has the problem that since it is bilayer tablets, tablets, not all the colors seems to appear on the same side of the tablet on the blister packing machine. So is it possible to detect all the defects in the system or on the blister line?
So we have a bilayer tablet with two
Yes.
colors, I suppose.
Yeah.
And only one type of combination of this bilayer.
Oh, so there can be two types of combinations. So if suppose white and red is a combination, some tablets may have red face upward, and some tablets may have white
Okay,
face upward
in the same recipe.
in the same recipe. So
Okay,
can BI Smart be used here?
in principle, yes. We never meet this type of challenge. We have meet the other challenge, like we have two different color piece, but with two different color schema, but not bilayer. But in principle, yes, we can do. In any case, my suggestion is contact anyone from Jekson team. Just ask a POC or a feasibility, and it's very easy to have the answer.
Okay, so I guess yes is the answer. We have a second next question from Harish. Is there future for self-adjusting of QR print quality based on camera scan? AI algorithm which self-adjusts print quality.
Where is it? This question
It is in
in chat?
Q&A.
Okay. Sorry, I try to read because self-adjusting QR point quality based on camera scan. But okay, adjusting printing quality. So this is for printing point of view.
Yes, yes.
So yes, we have something that we are developing but we cannot anticipate too much. And it is something that is related to have a unique system to print and check. I don't want to say anymore. Thank you, Harish.
Okay. Regarding the bilayer tablet question, we have another objection. Two different colors is another thing, but bilayer is totally different. So he wants to understand from us, JP, that have we worked on bilayer tablets and have we given BI Smart on machines that have blister packing for bilayer tablets?
So yes, we've done bicolor tablets, that's for sure.
Okay.
So if the tablet has one color on one side, a different color on the other side, it's something that when you teach the system, of course you have to show blisters that will have some tablets on one side, some on the other side, so the computer can understand that these are the two colors that are acceptable. But totally, this is a application that we've done successfully.
Okay, so that answers the objection. Thank you, JP. Thank you, Pasquale.
Thank
If
you,
you have
everyone.
more questions,
Thank you.
please send us at marketing@jekson.com or please contact us on our phone, which is on our website. Thank you, JP. Thank you, Pasquale,
Thank you.
Thank you very
for
much.
taking out your time. And
Good
thank you,
evening.
everyone, for joining this webinar. I hope we have learned a lot in this webinar. And we welcome your questions at our email ID, marketing@jeksonvision.com. Thank you. So we have shared a feedback form in chat. Please take out 2 minutes of your time and please fill it up. We will love to hear from you about the feedback of the webinar. Thank you, everyone.